Good afternoon, everybody. I hope you'll enjoy your lunch and a very interesting discussion. So we're going to have a debate around the evolution of AI within the Enlighten Award winners' companies. Obviously, this is fairly prescient at this point in time, the evolution of AI and how it's accelerating within the companies. So I'd like to introduce the panel members. Maybe you could give them a little round of applause as they basically come up. So I'd like to start with Krish, who's the Senior Manager of Emerging Technologies and AI, a 2 times winner of the Enlightened AI Award. So you're very well qualified for this. So welcome, Krish. Then Gus van Heidenvoort. So my apologies for making a mistake with your name, I'm sure, but welcome. So Gus is the Chief Commercial Officer of ATA Mute. So welcome, Gus. Next, David Russell from Vortex, who's the CEO of Vortex Engineering. Welcome, David. Come all the way from Leamington Spa, where I come from as well in the UK. So congratulations. Next, Brian Bellino. Brian is the Global Business Development Director of Svenco? Sciencco. Sorry. Welcome, Brian. And another Brian Bellino, Global Business, who is the, sorry, Brian, I'm just getting the script here. Product Manager, Supervisor of Engineering, New Business Development for Interiors at Marelli. Welcome. So welcome, gentlemen. As I mentioned, we want to discuss about how AI is basically emerging, evolving from within your sort of company. So I think I need to start with Krish, the 2 times Enlightened AI Award winner. So maybe you can give us some of your insight into the evolution of this technology.
Sure. We started, of course, this is all in relation to using AI in the engineering simulation domain. Of course, many people are using AI in other areas as well, like data science or whatever, but they're mainly using LLM a lot more aggressively. But within the engineering simulation area, we started about maybe 2 or 3 years ago, actually using tools like Design Explorer from Altair, and Physics AI and Rapid Minus, a lot of AI offering from the Altair ecosystem. And this is something that we wanted to find out, what is the limitations and the opportunities of solving problems in engineering simulation. So we sort of looked at the area and classified some of the sort of problems that could be solved using some of the tools. And some of the areas are actually looking at predicting simulation results by using trained models. And the other area was actually using AI for looking at geometry, just purely 3D spatial problem, and being able to use that to identify maybe simulation results. So one example is when you have like a crash simulation, how can you use AI to detect whether something is buckling or collapsing? So before, we would actually have engineers, poring over the crash simulations and trying to figure out, hey, is things sort of crumpling? Is it bending? So now all the subjective sort of assessment could be now automated using these AI tools. And the other area is, of course, using AI for automation, and especially with all the advancement in things like ChatGPT 4 and 5, this is becoming more of a possibility in automating process. So now we're going from low code to no code sort of approach, which was demonstrated by a lot of help from the Altair team from the data science, where they actually try to do some proof of concept. And then the last area that we're looking at is how can we basically gather all the data from all the domains within from an organization, going from simulation, scheduling, project management, marketing, supply chain, and actually put that into a database and using like smart querying, where you can actually ask a very generic problem. Like ideally, you can say something like, hey, the program needs to basically finish within let's say next month, but actually we're not ready yet. We need another 4 more months to go. It'd be quite nice if we can say, hey, what can I get within 1 month? So it'd be very good. Like the future of AI can actually help us come up with informative data to help the decision makers.
So essentially, there seems to be 2 areas emerging within that engineering function. One is obviously trying to accelerate simulation assessments using AI and tools like physics AI. And then from an automation perspective, the deployment of large language models in order to facilitate that type of optimization. So they seem to be 2 areas that seem to be emerging, and I think Lucid have been very open to drive them sort of areas. I think, David, obviously your space is the crash space. Maybe Krish has got a bigger computer than you and can generate more data, but what's your view, particularly when we're discussing about crash?
So yes, I'm going to approach this purely from a crash optimization perspective. So we have seen some uptake, I'd say, in terms of interest from the OEMs in the research centers. But what we've yet to see is that filter down and be used with anger in a production environment. And there are a number of, I'd say, cultural and technical issues to overcome. So from a cultural perspective, as a CAE engineer myself, we are taught from a very early on in our career to be very rigorous in the models that we run. There's a huge amount of Q&A. We are told to assess everything from the types of materials that we use, how they're defined, all the way up to connection methods, all the way through to full simulation. So with AI, we are now being told that we can use effectively a box of almost black magic to improve our current designs. There's naturally going to be a huge amount of suspicion from engineers such as myself as to, are these solutions valid? Can they be verified? And on the other side, we also have an issue, I'd say, where we've seen quite a lot of success with LLMs, certainly over the past couple of years. But it's important to remember exactly what AI is in terms of how it works. I mean, it certainly had, I'd say, a very good PR strategy behind it. But if we boil down into it, what really is it's interpolation of data sets using statistics. And with anything involving statistics, the quality of the outputs is always going to be very heavily dependent on the input set to which it's working upon. So AI works really well where we have dense data, which is very relevant to the question that we're going to later ask of it. It also needs to be unbiased in its nature. And with crash models, it's incredibly expensive to produce data points. So with LLMs, they've been trained using almost the entire internet. OEMs, we simply don't have that luxury of having those very large data sets to operate upon. And so just from a fundamental level, it's going to be very challenging to, I think, to utilize AI effectively.
Yeah, I think crash is probably, from an engineering perspective, is a really complex event, moving boundaries. And I think with Lucid, I mean, one of their examples was more breaking it down to just things like crush cans and things like this, which I think was a really good place to sort of start. So I think commencing the journey is really key. So I think I'd like to come on to Brian Bolello and some of your examples within your company. Are you seeing the rise of AI within your company? What sort of applications are you seeing?
So Science Co. started our AI journey, we started several years ago, and we're looking at it across functions in the organization, primarily marketing and R&D, but also in manufacturing and supply chain. Where we've really seen a lot of success, and we've partnered with Microsoft on the AI part of it, but we'll usually start with, on the software side for virtual engineering with Altair software. So if I take an example of an electric motor, what we do is typically do virtual engineering using our solutions. In this case, it would be a slot liner and the magnet wire. And we run models to come up with the best way to maximize the e-motor efficiency. So we do that through enhancing copper slot fill. So taking all that input, when we move from the virtual environment to the actual environment where we're doing material science development, this is where AI comes into play. So AI can propose to us different molecules to build with, different additives to apply to those molecules. So the combination of that eliminates several DOE steps, but I would say that it shortens the process, but it doesn't take away the validation. So actually coming up with the solutions that you can design quicker in R&D, AI certainly benefits you there, but you still have to run through validation to come up with a correct assessment of whether the material is going to demonstrate what it said it would do in the virtual engineering model.
Yeah. Anything outside the engineering space in your company?
Yeah, so in the marketing, we've really adopted it. So what we'll do in marketing, if we have a commercial application, a specific customer, we'll look at where we can take that application and apply it or share it with other customers in the market. So marketing, we've really accelerated the use of AI over the last 2 years in terms of going to customers and going to market faster. And essentially that's really paid off. It brings us to market faster. It brings innovation to market faster. And at the end, the OEMs and the tiers are the ones that really benefit.
Yeah, thank you. Brian Bober, I mean, any impact in the design area that you're seeing, or?
Yeah, I'll approach AI from a different kind of angle. Again, I'm coming from the design world, not so much the analysis world. So where we took it at Morelli is we actually partnered with a local university, Lawrence Tech, who has an AI program there. And we actually tried to do generative AI to design a functional automotive part. Literally, for those that know interiors, we gave it styling surface. It has no thickness, it has no clip towers, no attachment features, and tried to train the model with the student on how to have AI design develop the part, doing all the thinking that an engineer kind of intrinsically knows after years or decades of their experience, where a part clip tower should go, where ribs should go for strength and rigidity. And what we found was, think of AI kind of like a baby. For those of you that have had kids, you start out with a new model or a new problem. The AI model is literally a toddler. You have to start teaching it the code, teaching it everything. It's great. Chat GPT was mentioned. There's been years or decades of prior work that's gone into that we literally just started creating. And once we built the model and were able to get it to work, as soon as we changed one variable of the styling surface or a part thickness, what we found is that the model just blew up. So then you have to go into a loop of training it what to do when XYZ happens or occurs. Yeah.
So, I mean, is that a mixture? Sorry, is that a mixture of the sort of chatbots within the software itself, or is that more of a large language model overarching these individual design tools?
It's an overarching issue or an overarching matter, because we didn't run this, the student at Lawrence Tech didn't run anything through a Chat GPT or Croc, anything else like that. It was literally homemade coding of how to do this, what to do that, if this, then that type steps. So it was made from the ground up.
Yeah, okay. And then Gus, you're the young startup. I mean, you've got a clean slate. Is there any areas that you see at the moment?
Yeah, I think it's an advantage to have a clean slate. So I can take away a lot of the learnings I hear in this session, but also in the previous sessions. We are working on a data set right now to improve our product, because we have a product that is a physical thing. And what we want to do is improve it with some digital twinning as well. And yeah, that would be speeding up our development of the product. So that's why we want to use AI for. I agree about the validation. We should validate because AI is not a magic box. It still needs man's work to improve your product, but you can use AI to speed up your product, speed up your development. That's my opinion about it right now, and I think we're going to implement it likewise.
Has anybody got any comments relating to the speed of this adoption at the moment? I know from my own personal experience that I'd say that every month I'm shown something that I find really extraordinary. I mean, recently relating to simulation, one of my colleagues showed me about how he could ask a chatbot to say, automatically write script to do certain operations inside one of our pieces of software, which I thought was amazing because the large language model had absorbed all of our manuals. Just incredible. So has anybody got any comments about how this is accelerating?
In my previous, I worked in IT in my previous engagement, and as long as you are the architect of the code you are writing, you can have AI do the typing, but you have to be aware that you have to validate everything you build, because if you just write the prompt and say and ask about the outcome, the code you are producing is not of high quality.
Yeah.
So, I mean, I would agree with that. I think where AI will play a real strength is in being a debugger for code. I do also think that we're not at a place yet where AI can be trusted to design full architecture with full context. I am also a little bit concerned that at some point in the future there will be a data breach caused by a company using AI to write a secure bit of code. I think it is a matter of time. So I think it's a mixed bag.
You're not talking about JLR in the Midlands at the moment, are you?
Not particularly, but now you mention it.
Yeah, and you need to be aware that it's not a magic box. It's an aid, and it can help you speed up the process. But be aware of the loopholes.
Trust, but double check.
I mean, it does also present another attack vector. So I've seen some publications recently where it's been demonstrated that you can install sleeper agents inside AI firmware to become live at a certain date and time. So when you're in the testing phase of these models, they appear completely benign. But at a later date in the future, they can deploy a second routine and contain some quite malicious code. So we need to be very careful.
So, I mean, with that, any final thoughts that you feel you would like to leave the audience with, essentially? I mean, Krish, I think the engineering space is a really tough space to get this technology started, and I think that's your challenge at this point in time.
Yeah, so my sort of final thought, definitely agree with all the concerns that have been raised by the panel. Definitely, we have to validate what we're doing, and the adoption is slow, I think, primarily because the understanding is challenging, and also trying to figure out how do you basically use this technology as well. And it's pretty new as well. I'm sure just when FE first came along, I can remember when I first started off, people couldn't understand how FE can actually produce displacement. And I think we're sort of at the same point where there's technology that we don't fully understand, and it's not magic, it is based on maths, there are some fundamentals, principles based on it. But I think we just have to basically test out the technology. And the most important thing, just like when FE first came out, you can't use it divorced of domain expertise, because there is the actual development side and the domain expertise as well. And both sort of work together to basically improve the product and to basically deploy it. So I would sort of say that yes, we have to be, cautious in understanding how it works and how best to use it. But also, it is, at least from my point of view, it's definitely a very exciting time to be in, because I've been working in this industry in simulation for the past 30 years, and I've never been so excited. I never thought I'd be this excited, sort of at this stage of my career, where there's technology which can actually, change the way we do things, which is, I would say it's, the only thing which is holding us back is just our lack of imagination. There's so many problems we can solve, and it's just a matter of figuring out how to solve it. So there's lots of potential for sure in many, many areas, not just in simulation, but in automation, and looking at a future where non-expert people can actually drive simulation. It's not coming tomorrow, but I'm sure it's coming soon.
So the message is more energy required in that engineering space,
That's
essentially.
Right. Yeah.
I mean, I guess when you look at Lucid, it's got a very innovative sort of product. Each design is obviously extending increased performances, different strategies for construction. So I guess the amount of learning that you can drive historically into the new platform at this point in time is limited, but that concept of keeping on transferring that learning until essentially increasingly the AI can have more contribution than just the actual physics that we're calculating fresh each time. That's the way you see this going.
That's right.
I
think we just have to keep pushing and trying different approaches and see what works. And definitely what wasn't possible maybe a year ago is now possible and very easy, just because of the advancement in some of these large language model, which is quite surprising for most people.
Yeah. So I mean, you've started on that journey, and I think, as you're saying about the baby and educating and until it becomes a very sophisticated adult. So I think that start is really key.
That's right.
And then Gus, it's not magic, you said. I mean, so where do you see it?
Yeah, it's not magic, and you shouldn't be afraid of it. I see a resemblance when back in the end of the 90s, where the internet came up. People were afraid of it, of the technology. It was, some people say it was bad, but I think it's an innovation. It will bring people, will bring more for people. For instance, you can calculate way faster, and with the AI and the new chip technologies. So I think if we use it positively, then it will bring a lot more for mankind.
David, one day then using AI for crash, you think maybe? Or I definitely see that there is lots of energy being put into this area. I mean, I think Volkswagen are very public about the amount of crash data they've been collecting, both test data, simulation data. But you think it's still a way off at the moment, huh?
I think there is a long way to go before we're seeing it to be used for brand new architectures. It could potentially be used for some smaller sub-case studies where the range of parameters is quite narrow, certainly in the early stages. I mean, in an ideal world, we would see a collaboration between large OEMs, but I don't see OEMs sharing commercially sensitive crash data with each other in order to train these models. So I think each OEM will have to develop this capability on their own in many ways. So I think we are quite a long way off from where we need to be. in order for it to be used to design something really quite complicated. I mean, we do occasionally see in the media examples of vehicles that have been designed using AI, but when you dig a little bit deeper, you sort of realize they're just using some fairly classical topometry methods. So topometry, they say, well, this has been designed by a computer, the media picks this up. Well, if it's been designed by a computer, it must be AI. And it's important to differentiate between the two, I think.
Yeah. And I think a lot of the conversation is at least it can provide you with a better starting point at this point in time. So rather than, you know, the clean slate, then maybe it's providing a better starting point.
I mean, yes and no. I do think classical methods for optimization do have a lot of legs left in them. I think where AI really thrives is where you do have a lot of historical data to work with, and you don't really have a clear idea as to how to best process that data with a more of a bespoke algorithm. But like I say, I think the size and the scope of the data sets that would be required to be effective in this is going to be incredibly limiting. It's not just about running these models, it's about how do we go about quantifying performances for these models as well. Yeah. And that is a very challenging skill to have, I think.
Yeah, I think crash is the top tier. Huh?
I think it's probably the most difficult application for it, sure.
Yeah.
For sure.
Yeah, yeah. And Brian Bellino, you've got some really concrete examples already at your company where it's making that impact. I mean, what do you see in the future? Picking off more applications that are going to be matured and impact production? I mean, where do you see it going?
To start today, I mean, we really see AI as a tool, a useful tool. But in the end, our materials are used, they're injection molded, they're extruded, they're used in hardware applications. So while we can shorten the amount of design time to come up with formulations, we still need to do the mechanical testing, the chemical resistance testing, because they are going into hardware application. It certainly shortens the design cycle, but at the same time, it doesn't replace the need to do practical testing on articles, demonstrate that what you've developed work for fitness and use.
Thank you, Brian. And then you're teaching this child at the moment as quick as you can. Are you trying to accelerate that aging process? Where do you see things going at the moment?
I think we all on stage and here in attendance can agree that AI is going to be one of the best tools out there. You know, as other speakers have noted, it's a additional tool to be used, not necessarily a replacement. I think one of the biggest challenges, though, with AI is also going to be, you know, as you spoke with data security, is all of our IT infrastructures. You know, for us, IT firewalls, you can't get to certain sites, you can't do downloads. For us at Morelli, we've actually made our own AI chatbot or AI tool that feeds off of the typical chat GPTs and tools like that, because it is an IT data security issue. As you noted, OEMs aren't going to be sharing crash data with each other. That's forbidden fruit type thing to turn over. So what we've done with our own internal one is make sure that it's IT secure, it's okay and blessed by our global IT group. But then we've also been able to add to that internal chatbot, internal AI tool, all the three-letter acronyms that we love in the engineering world that simply would make ChatGPT go, WTF, what are you talking about? You know, it just doesn't make sense. But to us, we know what ABC, XYZ, what all these acronyms mean on a day-to-day basis. So I think that's going to be one of the biggest issues, that as great as everybody sees vision, future, potential, there still needs to be data security, and that's something that I think a lot of people don't talk about. Again, in training the baby, making sure that your teenager doesn't steal the keys to the car and go out for a wild ride type thing.
Yeah, okay. Thank you. I mean, I've got the luxury of globally visiting many of our sort of OEMs and tier suppliers in the automotive area. I mean, I do see this acceleration. I mean, I think you have to pick the physics, particularly that you want to represent. I mean, great examples that I've seen are basically metal stamping, which again is quite a non-linear type of behavior, but ultimately the consumer of that data is is a forming engineer who doesn't want to get involved in that type of assessment. You know, it's long run times. So, and the geometric deep learning is ideal at capturing that type of geometric behavior as well. So, you know, there are areas, we see it a lot now in the supply chain, even for complex things like airbag deployment or bumper systems, because you have the repeatability there within them sort of systems. So, I mean, we definitely see this emergence, and it is coming pretty rapidly. So I think it's what you're currently seeing. So I don't know whether there's any questions from the audience at this point in time to ask the panel at all. I think you've all communicated really well there. We don't have any questions. So I think with that, could you give a big round of applause to our panelists, please?